Hello everyone, this is Sajid Pareed from IIT Delft. In this video, I'm going to show you how can we compute biomass water productivity and crop water productivity given seasonal evapotranspiration and biomass production. You are provided with seasonal evapotranspiration, actual evapotranspiration and biomass production for a command area, a branch canal, which is NLBC and Humasagi branch canal area in NLBC. So let us start by adding the layers. First, I will add the data directory into the favorite so that I can access it easily. And you can see that these are the layers which I have already provided to you. So I'm going to add all of them. There is biomass, the actual evapotranspiration, crop type, and the CCA1 boundary. I will change the style of the boundary to a transparent fill to make it easy to view. This is a crop type map. This is actual evapotranspiration and biomass. So given actual evapotranspiration and biomass, we can compute the biomass water productivity, which can be computed using the formula biomass production divided by ETa, which is very easy to do in QGIS. Before we go ahead with the analysis, let us save the project. So I will save the project. Analysis, give a suitable name, and let's compute biomass water productivity, which is actual evapotranspiration, biomass production divided by actual evapotranspiration. You also need to know the units of these layers. So the unit of actual evapotranspiration is mm per season, and biomass is kilogram per hectare. And both these layers represent the Kharif season in 2019. So to compute water productivity in kilogram per meter cube, you have to divide biomass divided by actual evapotranspiration multiplied by 10. Then the unit of water productivity will be kilogram per meter cube. So let's do that using the raster calculator here. Biomass divided by, I will open a bracket, actual evapotranspiration multiply by 10, close the bracket, and give an output name. So I'll create a new folder for all the outputs, and I will say this WPP Kharif 2019 CCA1. After setting all this, you can run the calculator, and you can see it is already. Even though the minimum and maximum varies a lot, that those low and high values could be outliers. So if you check the histogram of the biomass water productivity, you can see that most of the values are within the range of 1 and 4. Now, the next step is to calculate crop water productivity. So in this exercise, we will focus on paddy because the major crop in CCA1 is paddy, which is represented by the class 2, which is also given in the slides. Class number 2 is paddy in crop type map. So we want to calculate crop water productivity only for paddy. We can adjust the style of this crop type map a bit to make it look nice. Classify. There are only 4 classes. Maybe you can just set the labels, paddy, breadcrumb, and others. And for time being, we are only interested in paddy in CCM1. And these classes are already given here for your information. So to compute water productivity of paddy in CCA1, the first step we need to do is to mask out actual evapotranspiration and biomass for paddy. For that, let us use a module called r.mask.rast. Name of the raster map to use as mask is crop type. Name of raster map to which apply the mask is, let us apply the mask to biomass first. And here it is asking which values to be used for mask. So as we know, paddy is pixel value 2. Let us put 2 there. You can put the rest other parameters as default. I will go to the analysis folder and give a name. If 2019 C1 paddy. So this is biomass only for paddy. Run it, run the module, and it should give you error. So let us see if it worked. Yes. So I can switch off the entire biomass map, biomass water productivity, and here you can see that we extracted the biomass only for paddy. Similarly, let us extract actual evapotranspiration only for paddy. So I select crop type as mask. I will select ETa to which apply the mask and set the raster value to use for mask as 2 and give an output name. So here this is ETA. Save and run. Once it's done, you can close the module. Here you can see that the ETA is also extracted only for paddy here. Now given we have actual evapotranspiration and biomass extracted only for paddy, let us compute crop water productivity for paddy. So crop water productivity is given by the formula yield divided by ETA. So the first step is to compute yield. To compute yield, fresh yield, the formula is harvest index multiplied by biomass divided by 1 minus moisture content. And for paddy, from literature and from field experiments, the harvest index, we have fixed our harvest index in the region as 0.47 and moisture content as 0.12. So let's apply this equation again using as a calculator. Go to as a calculator. I will open a bracket and I will select biomass for paddy multiply by the harvest index value is 0.47. Close the bracket. It's better to use the button here, divided by 1 minus moisture content. So open the bracket, 1 minus 0.12, close the bracket. So this equation will give you yield estimate for paddy. So here I'm going to give the name as yield. 2019 CCA1 paddy.diff. Save it and run the module, and you get the paddy yield for paddy. Remember the unit of yield is kilogram per hectare, because biomass is in kilogram per hectare. Again, if you check the histogram of yield, you can see that most of the yield is from 5,000 to 10,000, with a mean around 7 to 8,000 kilogram per hectare. So we have the yield map for paddy now. Now let us compute the crop water productivity. And crop water productivity is now simple. It is yield divided by ETa. Like before, if you want to get crop water productivity in kilogram per meter cube, we have to multiply the ETa by 10. It's unit conversion. So let's again go to raster calculator. Yield divided by ETA for paddy. Let's open the bracket to make sure there's no errors. Multiply by 10, close the bracket. Then I will set a output file name, which is WPY, which is yield water productivity. Save it, and this water productivity yield is only for paddy. CCA1, and I will run it. Again, I would compute the stat to see what is the mean. You can see that most of there are some outliers, but majority of the water productivities are fall between 1 and 1.5. It's also useful to know the statistics. So you can just type as the statistics, like statistics here, select WPY, and then just run it. Here you can see that the mean crop water productivity in CCA1 for paddy is around 1.18 kilogram per meter cube. So that is yield water productivity. Now we have yield in kilogram per hectare. It is a custom that we always yield in tons per hectare. So kilogram per hectare can be converted into ton by dividing it by 1,000. So you can just select yield divided by 1,000 will give you yield in tons. So that is the yield in tons. So let us see the average yield in tons, which is again the mean around 7 tons per hectare is the average yield obtained from CCA1 for 2019 Kharif season. So that is water productivity estimation if you have actual evapotranspiration and biomass um, obtained from PYs above. Now let us save the project. Now one more step is left, which is the calculation of relative water deficit, which will give you an idea about adequacy of the system. So the relative water deficit is calculated using the formula 1 minus actual evapotranspiration divided by maximum crop ET, which is the potential ET. In this case, we consider it as a maximum crop ET calculated from ETA, and arbitrarily it can be calculated as 99 percentile of ETA in CCA1. So let us compute 99 percentile of ETA. To compute 99 percentile of ETA, I will use a module called r.univar, and I will select the ETA for paddy. again, because RWD is crop specific, so we are going to compute relative water deficit for paddy in CCA1. So I'll select ETA paddy in CCA1, and the percentile to calculate I will put here as 99, and I will say calculate extended statistics. This option is very important because percentile belongs to extended statistics, so you have to select that. The field separator I will select comma, and we have to save it into a text file, which univar ETA univar. You can also do univariate statistics for yield or water productivity for more information, statistical information. And I will run the module. It is finished. I'll go to that particular folder. So you can see that there's a text file. I will open it in Notepad++, or you can also open that in an Excel sheet. I think that will be more readable. So there's a blank Excel file. Just drag and drop the text file here. It is a comma separated text file. So I will select the first column, go to data, text to columns, delimited. It is comma, finish. So you can see that R.Univer gave a lot of statistics like minimum, maximum, range, mean, the standard deviation. You can see that the mean ETA for paddy in CCA1 is 667 millimeter per season. And the last column is percentile for 99. And percentile 99 is 909.38. So I will take that value and use this equation, use that value as ETM to compute RWD for paddy. So let's go back to raster calculator, and I will type 1 minus ETA for paddy divided by the 99 percentile, which is 909.38. Close the bracket, and it will give you RWD for paddy, relative water deficit. So I compute that, and here you can see that it's mostly from 0 to around 40%. So that is how you can compute yield water productivity and RWD for a particular crop inside a boundary given seasonal actual evapotranspiration and biomass production. Thank you.